Hello, this is Mrs. Repasky with a lesson about writing names and formulas for ionic compounds. When ions combine, positive ions will combine with negative ions as individuals or as multiples so that the total charge adds to 0. And you think about your ionic compound. If you have a name like sodium chloride, you may already have the formulas memorized, or you may need to look at an ion chart. So here I have sodium. Sodium is an alkali metal in the first column of the periodic table. It always prefers to have a charge of +1. And chlorine is a halogen in the 17th column on the periodic table, second to last column, and it prefers to have a charge of -1. So when I put them together, this 1 and the 1, to figure out what the subscripts are, I take the charge of the one and I give it to the other. I cross them once again, and there, I'll have my formula. The whole point of figuring out how many ions I have is so that the total charge adds to 0. So the plus and the minus cancel, so I get rid of the charge. And when I write the formula, no charges are included because they've canceled each other out and effectively they add to 0. So the formula for sodium chloride is Na1Cl1. In chemical formulas, a 1 is written as understood, so that means that the 1s aren't written in. So when we see the formula for sodium chloride written as NaCl, that means I have 1 Na and 1 Cl, and we just say NaCl. The same ion can react with several other ions, and you only need to know the names of the ions to know the names of your compounds. So copper 2 chloride is the next compound. Notice that the copper has a Roman numeral 2. Copper is a transition metal. Many transition metals form different ions with different charges. So putting a Roman numeral in the name identifies what the charge is. Copper can be a +1 ion or a +2 ion, so the Roman numeral lets us know which one we have. So since the copper is a +2, we'll make that a +2. And the chloride is always -1. Oops, -1. So I have a Cu +2 and a Cl -1. I take the charge from one and I give it to the other. I cross it again, and there I have my formula. The whole point of crisscrossing is to add them to 0. So together they act as if they have no charge. They make a 0. So I have Cu1Cl2. A 1 is understood, so the 1 goes away. And when you write the final formula for copper 2 chloride, you write it as CuCl2. The next example is aluminum oxide. Al forms an ion with a +3 charge. Oxide has a -2 charge. So I do the same thing. I take the charge from the one and I give it to the other, cross them once again, and then I write my formula. Chem is so much fun, I'm going to teach it to another. Add it up to 0. Okay? So aluminum oxide is Al2O3. Iron 2 sulfate is the next example. Iron's a transition metal, and it forms 2 ions, a +2 and a +3. So here I have the +2. So make that a +2. Sulfate is called a polyatomic ion. because it has more than one atom to make that ion. I can tell it has more than one atom because I have two capital letters. So I take the charge from the one and I give it to the other, cross it once again, and then I have my formula. Chem is so much fun, I'm gonna teach it to another. Add them up to 0. Hey! They end up with the same subscript. If both ions have the same subscript, then they can cancel out. And this is called the empirical formula. You reduce it to the simplest form. And this is FeSO4. So this 4 is counting how many oxygens, and it is part of the definition of the sulfate ion. Well, let's consider the two different ions of iron and how it's important to think about those when we write the names and the formulas of a compound. One compound is iron 2 oxide and the other is iron 3 oxide. And possibly you think that, hey, it would be just easy if I said iron oxide. And sometimes we do just say iron oxide, but when we want a formula and we want to write a balanced equation, we need to know which is which because the ratio is really important. So iron 2 oxide, the Roman numeral 2 indicates that the iron has a +2 charge. Oxide is always a -2. Iron 3 is Fe+3. And the oxide is going to be -2. So if I do the top one, I take the charge from the one and I give it to the other, cross them once again, and then I write my formula. Chem is so much fun, I'm gonna teach it to another. Add them up to 0. So I have Fe2O2. The 2's are the same number. We can divide each by 2 and reduce them to 1. So this is FeO. For the second version, I have iron 3 oxide. So I take the 3 and I crisscross over, so the 3 becomes the subscript of the O. I cross the 2 over, and the 2 becomes the subscript of the Fe. I do that so the charges add to 0. They cancel each other out. So I don't write the charge when I write the final formula. This time, the final formula is Fe2O3. Notice they have the same letters, but they have different subscripts. The different subscripts indicate that they are different compounds, and they'll have different properties. FeO, iron 2 oxide, is your normal reddish rust. Fe2O3, iron 3 oxide, is formed at a faster rate and at a higher temperature and has a blue color. The next example is calcium hydroxide. Calcium is Ca+2, and hydroxide is OH-1. So I take the charge of the one and I give it to the other. Cross them once again, and there I have my formula. I'm crossing them so their charges add to 0. So I have CaOH2. The 1 can go away. I don't need to write the 1. So I've crisscrossed, but now I have hydroxide that is a polyatomic ion, and I have this 2. I know that this 2 is a multiplier, but is it telling me that I have 2 H's, 2 O's, or that I have 2 sets? We could write it as CaO2H2, but then I'd lose the simple way of showing hydroxide as OH. So when we use polyatomic ions and we have multiples of them, we put them inside parentheses. So having the parentheses here indicates that we have a set of OH. So this 2 is written outside of the parentheses and it multiplies the entire set. So calcium hydroxide is Ca, OH inside the parentheses and a subscript 2. The 2 does multiply the entire thing. If you needed to count your atoms, there are 2 H's and there are 2 O's. Well, we write them like this so it's easier to identify that we have 2 sets. The parentheses indicate that that's a set. Right? These go together. And my last example is calcium phosphate. Calcium is a +2. And phosphate is a -3. That's not a minus sign. It's a minus sign. So a +2 with a -3. So the charge of the one is the subscript of the other. Cross them once again and then you'll write your formula. Chem is so much fun, we gotta tell it to another. Add your ions to 0. The charges add to 0. So we have 3 calcium atoms, and that's easy to identify. But phosphate now has 2 subscripts. We've got the 4 and the 2. Well, phosphate is the set of atoms, a P and 4 O's. So we write it as Ca subscript 3, put a PO4 inside the parentheses and a 2 outside. So let's see how reading these subscripts work. If a subscript is written immediately after an element symbol, as this 3 is, the 3 multiplies back 1 capital letter. So this 3 goes with the tiny a and the capital C. The capital C, lowercase a, makes calcium. So this 3 indicates that there are 3 calciums. Inside the parentheses, we have PO4. This 4 is written next to 1 capital letter. So this 4 is multiplying the oxygen. And that is all the influence that it has. The phosphorus, with the capital P, has its own subscript, which is a 1. A 1 is always understood in chemical formulas. That way it doesn't get too crowded. There aren't too many things to read. So there's 1 phosphorus atom for every 4 oxygen atoms. So a phosphate is made of 5 total atoms, a phosphorus with 4 oxygens. In calcium phosphate, we need this multiplier of 2. So a subscript written outside of the parentheses can be distributed throughout the entire parentheses. So this 2 multiplies the 4 and the 2 multiplies the phosphorus. So if we were needed to count all the atoms, then we'd have 2 times 4, and that would give us 8 oxygens, and 2 times 1, which gives us 2 phosphorus atoms. If we wrote the formula as Ca3P2O8, that would be a correct chemical formula. But figuring out the name of P2O8 gets complex, because P2O8 and PO4 having 2 of them, they mean the same thing. So scientists have just agreed that if we have a set, PO4, we're just going to reduce it to PO4 and write it in parentheses. Leave it here, that way everyone can recognize it as phosphate. And then we'll use the multiplier to say, hey, we need 2 of this full set. Just makes things easier. After this portion of the video, I have a photograph of the answer key for all the compounds with the name, the formulas, and the names of everything I did in this video. Thank you for watching. I hope it was helpful to you.